Let's get going with lesson 10. Pause the video, have a go in your own time, and then I'll see you in a minute to have a go at the answer. Answer to this one, not possible. There are 1, 2, 3, 4, 5 variables and only 2 equations. So there we go, we can't solve that one. Not possible. Next question. Have a go at this in your own time. That's supposed to be a plus sign. Okay. I'm going to answer this by rearranging. I'm going to minus 2 from both sides first. 11x equals minus 2. Now I'm going to divide by 11. X equals minus 2 over 11. There we go. That's that one. Another solve question incoming. Have a go at this in your own time. And the answer is not possible. There are 2 variables and only 1 equation. Let's do the next question. If I can get my pen to work. I'm just going to tidy that up. Let's have the equal signs on top of each other. There we go. Have a go in your own time. It's pretty normal to have the equal signs on top of each other when you're writing more than one equation. One equation, 2 unknowns. Okay, this should be possible. In fact, it is, and it will turn out that a equals 5 and b equals 5. So you can skip to the next question if you like. Otherwise, I'm going to show you the working. Obviously, stay and look at the working if you couldn't do it. I would think that seemed like a good idea. I'm going to combine these. We know that a equals b, so I'm going to rewrite the first equation as a plus, and then I'm just going to write a, because a is the same as b, equals 10. So that means that 2a equals b. What I've done there is I've simplified. Then I'm going to divide by 2. So it'll be a equals 10 divided by 2 equals 5. Boom, boom. That's the first one. And then we know, let's use a different colour. Using these two, 5 equals b, because I've just put the value for a into the second equation. But I'll just rearrange that because I always like to have the letter at the start. B equals 5. There we go. So we've confirmed that one as well. Oh, what just happened there? Okay, let's do the next question. Have a go in your own time. How are we going to do this? We are going to use by inspection, because we're going to look at it. Remember, inspection means to look at something. Oh, look, both sides have 2 to a power. So those powers obviously have to be the same, obviously. So that means that 3x plus 1 must be the same as 6. So now we can just solve it. It's minus 1 from both sides. 3x equals 6 minus, I'm going to be careful here, don't make a mistake, which is 5. Now I'm going to divide by 3. So that means that x equals 5 divided by 3. There we go, so that's the final answer. Next question. Have a go in your own time. That's supposed to be a 0. This is one of the rare occasions where I like to repeat a question exactly the same. Final answer is this. So, how do we do it? We can't solve it because there's 2 different things. There's an x squared and there's an x, and they're like 2 different types of thing. So that's having 2 variables in one equation. Oh, but there's a trick. What we're going to do is we're going to factorize. Just because we've recognized that it's a quadratic. I'm calling it a quadratic. A quadratic is like a name when there's like an x squared and there's an x and there's a number. Ish. And I'm going to factorize, and it turns out that this is what it is factorized. Let's just talk that process through this time. The way I do it is the first thing, so I'm going to undo that, I'm going to do it again. I'm going to put a plus sign here and a plus sign here. The first thing is to try and do this. How do I make x squared? Well, I put an x there and an x there. Let me just change the plus signs to green to make this clearer. And then the second thing that I do is I try and make the 6. How could I make 6? I could do 1 times 6, that works. Then the third thing I do is I try and make the 5. I basically check whether it makes the 5. So now I'm going to multiply it out. So I've got x squared plus 6x plus x plus 6. Wait a sec, this isn't going to work. That's x squared plus 7x. So I'm going to write, didn't work. Because if this were an exam, I don't like to cross things out. I'd rather leave it there just in case it gets me marks. So I'm going to try again. Okay, so let's try again. Well, the first one, it's got to be x and x. There's no other way to make x squared. Well, it's obviously not 1 and 6. So, well, actually, you can either do 1 times 6 or you can do 2 times 3. So I'm just going to do 2 times 3. I presume this will work. Let's check, because the third thing I like to do is then check it. So that's x squared plus 3x plus 2x plus 2 times 3 is 6, which is x squared plus 5x plus 6. Brilliant, that worked. Right, now, so what we do, run the line down, and remember we've now got two things multiplied together to make 0. So either the thing on the left equals 0, or the thing on the right equals 0. Which gives me two equations. So if I minus 2 from both sides, x plus 2 minus 2 equals minus 2, they cancel, gives me the final answer down there. This one I'm going to minus 3 from both sides, x plus 3 minus 3 equals minus 3, they cancel, so that ends up giving me the equation there. Ta-da! Done it. I'm just going to finish with one little closing thought, which is this stage here, which is called factorizing, which I'm sure a lot of you knew. There are many approaches to factorizing quadratics. I'm not going to particularly go into it in this course of 20 lessons, mainly because there are a number of different approaches, and for me, there is one which I think is best, but I only think it's best because I think it's more useful for algebra-heavy questions, where I think a lot of the harder marks are to get the higher grades. Anyway, but I don't think it's crucial for all students, blah blah blah. I go into that more in my maths book, which is available as a free ebook, or you can buy the paperback, including the playlist of over 100 videos on YouTube that works with it. So just to repeat, factorizing quadratics that we just did, I'm not going to go into it much more in this course of 20 lessons, but go and see my book and my other thing, and the other playlist, also free, to get some more input from me, and you may also want to get input from other teachers to get other ideas. Okay, here we go. Have a go at this one. See you back in a minute. I'm going to use by inspection, because I'm going to kind of predict, to make a quarter, if two things added together make a quarter, each one must be half the size. And what's half the size of a quarter? Well, that's a quarter there, and half of a quarter must be, it's obviously an eighth, so which means x must be 8. Boom, there you go. That works. Maybe you do it another way. Do you know what? Just this once, I'm just going to talk through, so you can skip to the next question if you like. I don't think this is particularly crucial, but in case you're wondering how you could do it using algebra. So this, to me, is a good way of doing it, generally, but it's a bad way of doing it in the context of this set of 20 lessons. Because in this set of 20 lessons, I've got some kind of learning aims, and one of them is developing key advanced skills in solving equations, which means moving beyond just using algebra, using things like by inspection, which are of vital importance. Anyway, blah blah blah. Let's just do this one using algebra. Just as an example, just so you can see how it could have been done. What's 1 over x plus 1 over x? It's just 2. It's 2 of them. You just add them together to make 2. Right, so I mean, to me it's obviously just 2 over x. But that's just, I've got the intuition from doing it for a long time. So instead, let's say, oh, well, they've both got the same common denominator, so I can just add them up like that. That's the way of thinking about it, doing it a bit more thoroughly. So that makes 2 over x equals 1 over 4. Now I'm going to times by x, which gives me 2 equals 1/4 times x. Now I'm going to times by 4, which will give me 2 times 4 equals x. So x equals 8. There you go. So could have done it with algebra. Let's do the next question. Right, the next question is a calculate. And this is a biggie. We've got a big list here, so I'll tell you when I've finished. So the list kind of carries on over here. I find this is a very useful exercise to do something of this, a pattern of this type, just to kind of understand fractions a bit more. Right, let's have a go in your own time, and then I'll just fill in the answers. Most people find some of these are easier than others, so fill in the ones you can do. Spend more time on the others, and you should see the pattern. Right, I'm going to go for it, and I'm going to try and do it the way I just encourage you to, which is to do the ones that look easier first. 20 over 20 is obviously 1. 20 over 1, that's obviously 20. Okay, that works. And oh, I can immediately see 20 over 0.5, that must be 40. Because I've just, yeah, that feels right to me. Trust me, that's correct. 20 over 10, that's 2, because the 20 is double 10. Oh, that's how to describe this one. That 20 over 10 is double. 20 is twice 10, so the answer, when there's a fraction, that's 2. 20 over 0.5, 20 is 40 lots of 0.5, so it's 40. So this one, what would... 1 over 0.1, well, that would be 10, so 20 of those must be 200. There you go, so that's that one. 20, let's leave 20 over 100 for a minute. 20 over 4, that goes in 4 times, so that's 4. 20 over 40, that's a half. 20 over 80, that's a quarter. This one's a tenth. Alright, question is, what is 20 over 0? You might say not possible. I would say that's a very good answer. Or you might say infinity. Oh, okay, I'm going to get rid of that line because it makes it look like it's a divide. Right, so it's either not possible, or you might say it's infinity. I'm going to say either's okay. I think I go on a bit more about infinity in my maths book. I'm not quite sure. Let's not worry about it too much. But if you've been learning about infinity a little bit, and fractions with zeros at the bottom, there's a bit of an explanation of why. You can see that as the number at the bottom gets smaller, so the result gets larger. So if you make it infinitely small, the answer will logically become infinitely big. There we go. That'll do there. Let's move on to the next question. It's another calculate. Just got 2 here, so I'll just write them both down, then you can have a go. And the answer is 1 and 3. Because if you had to give a reason, you could say because 1 times 1 equals 1, and because 3 times 3 times 3, because cubed root means what number times by itself 3 times will give you that number, is 27. Also, you can think about it as being the inverse of squaring and the inverse of cubing. Let's do another calculate. Have a go in your own time, then I'll write the answers down, then I'll do a little bit of working. 0, 1/8. Why? Because 0 times 0 times, I've lost the ability to write, times 0 equals 0. Yeah, yep. Why? Because a half times a half is 1 times 1 is 1, 2 times 2 is 4. But then I have to times it by another half as well. So 1 times 1 is 1, is an eighth. I'm going to go on about it again. If you said 1 over 6, not good. Really not good. Need to I know the reasons why, and I used to make mistakes like that. You just, the way I say it is, if there's something you tend to keep getting wrong, try and remember that you keep getting it wrong. It's like, oh, I'm always getting things wrong where it's fractions with indices. In which case, just concentrate harder and spend longer on it. Just to, in an exam context, you're dedicating a bit more time to help you get the marks. Okay, I like this kind of question. Simplify if possible. So it may not be possible. You might just have something which you can't do anything with. Maybe this is the simplest way to remember it, to write it. So remember that simplify means tidy up. So basically it's saying, can you find a way to tidy it up? If you can't, well then just leave it. Just say not possible. Here we go. Have a go in your own time. And the answers are 2x plus y, x squared y, x plus xy, and not possible. This one is not possible. I'll just briefly talk about this a little bit. X plus x is 2x. There you go. And then it's just plus y. X times x means x squared. So that's where the x squared comes from. So you could have said x squared times y to show a bit of working, and then you say, well, I don't need the times sign because I could just have two letters next to each other, and that means they're times together. So that's what's going on there. Let's look at this one here. X times y means xy. You don't need the times sign, so that's where that comes from. And that's it. You can't do anything else. Because remember our elephants and giraffes. You can't combine things that are different. In this case, the elephant is the x and the giraffe is the xy. They're two different things. They behave differently. If you drew a graph of them, the graph would look different. If you put numbers into them, the results are different. They're not the same thing. Okay. Similarly here, not possible is correct. It's not possible. It's not possible because an x is different from an x squared, and if they're added together, well, you can't simplify any more than that. All right, that's enough waffling. We haven't done this before. Make x the subject. I'm going to write the question. Pause the video to have a go in your own time. If you want a clue, if you don't know what subject means to be basically, let me write an equation. Q equals 15 m over L. Here, Q is the subject. It's, if you're talking about somebody, they're the subject of the conversation. And here the Q is the subject of the equation because the equation is talking about what Q is. There you go, that works as an explanation. Oh, I think I managed to explain that. Right, anyway, pause the video if you want to have a go. I need to make x the subject, which means I need to make x be on its own, so everything else has to disappear. So what can I do to both sides to make the 5 disappear? I can divide by 5 because it's the opposite of times. So I then end up with 5x divided by 5 equals y divided by 5. They cancel, so I've now got x equals y over 5. X is now the subject of the equation. Boom. Let's do an expand. Can you remember what the rest of this question will be? It will be and simplify. Because when we're given an expand question, typically we're asked to also simplify it. which means to tidy up the answer. So have a go in your own time, and then I'll do it. Okay, that is 11x squared plus 11x plus x plus 1. Write the final answer, 11x squared plus 12x plus 1. Like I've said before, go and see my maths book and the other playlist for more stuff on that subject. And there's lots of new material in this set of 20. I'm trying not to, and there's a lot of repetition. I'm trying not to repeat too many things, because you don't need to double up on all the material. And I've chosen to have a particular focus in this series of 20 lessons on certain things. Have a go in your own time, pause the video, see you back here in a sec, and the answers are 10, 25, 0 and 1. I like to keep drilling my students on the meanings of plus, times, minus and divide. In particular, notice that when we minus something from itself, then there's nothing left over. And when you divide something by itself, you get 1. This one here is interesting, because you know when you're like cancelling, you have like x squared over x. Well, that's x times x over x. They cancel, so it's just x. But you know when you have x over x, have you ever thought, well, how come when I cancel, there's still a 1? Well, here's your answer. That's why, because if you divide something by itself, it makes 1. If you divide something by itself, it makes 1. The way I think about it, I think this is correct. I think this, well, it's obviously correct, but I think this is the underlying reason. I'd have to debate it with a philosopher or something to be sure, but I think when you minus and add things and they cancel to 0. When you divide things, they cancel to 1. That's kind of the underlying truth there. But I'd need to debate that with someone just to be absolutely sure I wasn't missing some weird edge case or something. I mean, that's how I think about it anyway, and it works really well for me. Right, this is pretty grim. I apologise. Okay, have a go. Let me try and just write the answers first. This one is 7 over 2. This one is... Did I just do that wrong? No, I didn't. This is 7 over 3. Okay, yep, that's 3 over 2. That's 1 over 6. Now I'm going to explain all of them. This one, the way I did it is, and always do working. The only reason I just did that quickly is just because I want to show you. I've been doing maths for years and years and years, so I can do this kind of thing in my head, but in an exam, etc., I would never normally do this. And you heard me not being super sure as I was doing it. So let's check. Yeah, what I've done is I've made it so that the denominator is the same. I'm doing the thing, remember, make it look the same. A really, really important skill in maths. Often disguised as other skills, but in reality just one skill applied in many different areas. 7 over 2, fine. You might have also given your answer as just 3.5. That's fine. I didn't specify how to give the answer. Or maybe 3.5. Anyway, let's check the next one. The next one is kind of the same thing really, which is you've got a third, and then how do you write 2 as something over 3? That'd be 6 over 3, so that's 7 over 3. There we go. Right. This one, I always do this. So in my head I did this. I always turn the whole number into a fraction just to make it easy, just to be sure. So 1 times 3 is 3, 2 times 1 is 2. Boom, happy. I'm not going to go into this much in this course, but I'm just going to touch on it once. When we divide, we make a number smaller so it impacts the bottom, which means you simply times the 2 by 3, which makes 1 over 2 times 3, to 1 over 6. That's method number 1 to think about it. Approach number 2 for thinking about it would be, when you divide by 3, that's the same as, well, if you want to change that to a times sign, you have to then flip that number. So you, instead of being 3 over 1, it becomes 1 over 3. So when you change from a divide to a times, you flip the fraction, which then makes it 1 over 6. I was going to say another way to think about it, and I can't remember now. Anyway, that's fine. The point is, I'm sure there's other ways to think about it. There's multiple ways to think about this. This course isn't going to cover it, but just, this is a skill. If we just highlighted something you find difficult, you could go and practice it, or make a note of it, or ask a friend or a teacher or something, or at least be aware. Right, this is again, let's use the word function. This is the function topic, which we've already covered once. I'm not writing the question very clearly because I don't want to. I just want to kind of give you a thing to do without an actual question at this stage. So I'm writing down the answers to the first 3, and you have to try and deduce the answer to the last one. So pause the video, have a think. What's going on? What does G mean? What would G of 10 be? What would G of 10 be? And the answer is 20, because here you're timesing by 2. 0 times 2 is 0, 3 times 2 is 6, minus 1 times 2 is minus 2, and 10 times 2 is 20. But what we're doing there is we're familiarizing ourselves with how functions work. Do you know what? Let's extend this now. We've done that one together. We've checked our answers so far. How about you do the next ones? So pause the video if you like. Have a go. I'll see you back here and I'll write down my answers. Right, 0.2 times 2, that's 0.4. A half times 2, that's just 1. X times 2 is 2x, because that's 2 times x, yeah? Which we just write as 2x. We don't need to write the times sign. What about 2 times m plus 3? Oh, we just multiply it out, yeah? So that's 2m plus 6. There we go. Next question. This is the penultimate question. Factorize. I've just written that out wrong. Oops. Let's try again. Apologies. Have a go in your own time. Pausing the video, blah, blah, blah. Okay, they both got an A, but that one's only got one A, so we can only put one A outside the brackets. They both got a B squared. In fact, that's it, so the B's are dealt with. And there's only one C there, so we can only put one outside, which leaves us, what's got left to be inside? We need an A squared here. We need a C squared to make that one up. And that's the final answer. Last question. I'd like to have a go at plotting or sketching. Let's say sketch, because that way, if I say sketch, you don't have to do it neatly. You can just do a rough sketch, and that's fine. I'm going to do my answer. Right, so this is what it looks like. I'll show you, and then I'll talk it. Whoops, that's not quite. Let me just try and do it a bit more neatly. I wanted to touch the origin, so there's 0, 0 is a point. That's the answer. By the way, there's a bonus lesson with more sketching questions. And if you're happy, see you in the next lesson. If you want to hang around, we'll just talk about this a little bit. As usual, if you don't know how to do a graph sketch question, draw a table. So let's just go through that. I always put X and then Y in alphabetical order because I find that's much easier. So if X is 0, Y is 0 squared is 0. Okay, so that's that point there. If X is 1, Y is 1 squared, which is 1. Okay, so we can plot that. What if X is minus 1? Minus 1 squared, that's minus 1 times minus 1, which is 1. Oh, okay, right, so that goes there. Let's do minus 2. Well, I've done that now. What's minus 2 times minus 2? Well, that's obviously plus 4, so that goes there. But if it's 2 times 2 is 4. There we go, starting to see the pattern. There's a bonus video on this topic. See you there, or see you in the next lesson, something like that.